Okay, so now let's talk about rational functions and behavior. So one of the things, again, this goes back to algebra. Really, what I'm talking about here is just more of review from your days of algebra or pre-calculus. So remember that when it comes to rational functions, end behavior depends on the relationship between the polynomial on the top and the polynomial on the bottom. Okay, so remember, a rational expression is where we have a ratio, of two polynomial functions. Now remember, the relationship is between the degrees. Remember, if the degree on the top is bigger than the degree on the bottom, then guess what? The limits, remember again, these are continuous functions, so you can use the quotient rule. And so the limit of the top versus the limit of the bottom. Well, the degree of the top is bigger than the degree of the bottom, then this is going to go to infinity faster than this one. And so this whole thing will go to positive or negative infinity, depending. Okay? Now, also, if the degree of the top and the degree of the bottom are the same, then the limit of this thing is going to go to a real number. Okay? The ratio of the leading coefficients, if you remember, right? So remember, and so there's going to be a horizontal asymptote, right? And so it'll be at the horizontal asymptote at the ratio of the two leading coefficients. And then if the degree of the top, one more case. If the degree of the top is exactly one more than the degree of the bottom, then we have an oblique asymptote. Okay, but still, as far as the behavior goes, it still goes off to infinity. Okay, so whether there's an oblique asymptote or not in this case. So if we just look at the degree of the top being bigger than the degree of the bottom, then this limit, the limit of this function, is going to go to infinity, either positive or negative, depending on the relationship. If the degree of the top and the bottom are the same, then we're just going to, the limit is going to go to the ratio of the two leading coefficients. And if the degree on the bottom is bigger than the degree on the top, then this thing goes to 0. Okay? And so it'll have a horizontal asymptote at y equal to 0, the x-axis. Okay? Okay, so the technique, if you remember, is to divide the, if you have two polynomials, is divide the top and the bottom by the highest power of x that appears in the denominator. Okay? So if you do that, you're just going to divide the top and the bottom by the largest power of x that's in the denominator here. And what you're going to do is that will change the look of the function. It's not going to change the function, but it'll allow you to see where, as you take the limit, as x goes to positive or negative infinity, you'll see all the terms will go to 0 except 1 or 2. Okay, and then you'll see where the limit goes. Okay, but again, those are the basic shortcut rules that I've learned and that I've taught that go back to college algebra or pre-calculus. Okay, have a good day.